Okay, let's have a look at this question now. So let's have a look here. Z is x plus iy. Show on the Argand diagram the z plane the set h for which z minus 1 plus 4i is less than or equal to 1. Okay, so I think I'll rewrite that as z minus bracket 1 minus 4i less than or equal to 1. So what that will look like is this. We'll just call that 1 and I. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1 minus 4i is here. So what this equation represents is a circle of radius 1 at this point. So that should be touching there. So it's going to be a unit circle at 1 minus 4i. That's the, what do they call that, h. Now show on the Argand diagram in the W plane, fh, the image of h under the transformation. I'll just use the same diagram here. So what's happening here? Let's just have a look here. Fz. Yeah, so firstly, the z gets multiplied by minus 1. And then you add 1 to it. And then you multiply it by k. So this here is a reflection, isn't it? Yeah, it gets reflected through the imaginary axis. And then this is a translation to the right by 1 unit. And then this is a rescaling. And we have to show that we get this circle. Okay. I'll do that now in a second. I'll just sketch this out. So this will get reflected over to here. And then it gets translated to the right, so now it's here. And then it gets multiplied by k, so it gets pushed out k amount, but and we have to find the k. Okay. Well, according to this formula, this will get moved to minus I. It'll get moved to here with a radius of 1/4. So so it kind of looks like it kind of looks pretty obvious then. If it was at 0 minus 4i before you multiply them by k, and then after it's at, what did they say, minus I, so 0 minus I, then that means the k looks like it's 1/4. And we can, yeah. Yeah, I guess that's it. I don't know, I was kind of expecting it to be a bit more complicated. Yeah. Yeah, okay. just thought it'd be a bit more complicated. Hopefully I didn't make a mistake there. Alright. Z squared equals that. Show that Z equals that. Okay. So according to De Morvis's theorem, we'll have Z squared equals cos 2 alpha plus 2n pi. Yeah, plus I sine 2 alpha plus 2n pi. So De Morvis's theorem says we just multiply these by half, because we're going to square root both sides. So that's a half times 2 alpha plus 2n pi, and the same for sine. So we get Z equals cos alpha plus n pi. So we have Z equals cos n pi plus alpha plus I sine n pi plus alpha. Show that Z equals that. Okay. And we want to calculate Z squared. So in polar form. Alright, so this is going to be over here. So we can get the modulus. That's the or, I should say, which would be the x squared plus the y squared, where this is x and this is y. So I'll just be lazy and type this in on the calculator. Root 2 minus root 3, root 2, oh, was that, looks like it was a plus, wasn't it? So that works out to be 2. Isn't that a plus? Yeah, it is. And then the theta I can get by solving the equation tan theta equals minus root 2 plus root 3 over root 2 minus root 3. $75 degrees. Oh, but that would be not right. Because that's strange. That's strange. That's quite, I was expecting an answer more than 90. Huh. Oh, I forgot to type in the minus on my calculator. Yeah, okay. So that's theta is minus 75 degrees. Okay, so for the second part here, we have Z squared would be or squared cos 2 theta plus I sine 2 theta. So that would be 4, and then cos minus 150. That's minus root 3 over 2, and then sine minus 150 is minus a half I. So that's the Z squared in polar form. And deduce that cos 19 pi over 12. Oh, maybe I should have been using radians then. That's, by the way, that's 5 over 12 pi. So now deduce that cos 19 pi over 12 is that. So what do we know? We know that cos theta, cos 2 theta is minus that root 3 over 2, and we need to, and that's 150, minus 150. That's 5 pi over 6. So cos minus 5 pi over 6 is equal to minus root 3 over 2. Okay. Yeah, okay, that's right. So we need to get to 19 pi over 12. Yeah, okay. I think we can get there, but I need to make some space. So let's have a look here. Cos 19 over 12 pi, that's equal to cos 2 pi minus 5 pi over 6. So that's cos A, cos B, minus sine A, sine B, but sine 2 pi is 0 and cos 2 pi is 1. So that's just equal to cos minus 5 pi over 6. But that's minus root 3 over 2. Oh wait, hang on. Oh, hang on, 24. Oh, hang on. I think I made a mistake with my subtraction at the start, of all things. Okay, so that would be cos 24 minus 5 over 12 pi, right? So that's cos 2 pi minus 5 over 12 pi. So using the cos A minus B formula, that's equal to cos minus 5 over 12 pi. And I have 5 over 6. Ah, yeah, okay, so that's the original angle, isn't it? So if you let alpha equals minus 5 over 12 pi, then this is equal to cos alpha. And I think that's what this angle is here, or I called it theta anyways. Theta. Yeah, it is. It is. So it's just the original here. Good. Okay, we're sorted now. So that's the, let's get that now. That's the same as cos minus theta because cos is an even function. So what I can do is just not worry about the minus signs and just draw a triangle. And this side is root 2 plus root 3. And this side here is root 2 minus root 3. So I'm going to need to get the... but I do know it. It's 2 from here. So so I don't even have to use Pythagoras. I have it already from earlier. So that's equal to root 2 minus root 3 over 2. Yeah, fantastic. Okay, I was kind of worried that was going to be horrendous. But if you don't make simple arithmetic mistakes like I did at the start here, it's actually not too bad. I just made a mistake at the beginning here. So 19 over 12 I can write as 24 minus 5 over 12, which is 2 pi minus 5 over 12 pi, which simplifies to that. But because cos is even, it doesn't really matter if you have the plus or the minus in front of it. And this theta here is the same as the theta we had a moment ago. And the hypotenuse is the modulus that we just got. And so, yeah, it works out pretty nice then. Great, okay, I'm happy with that now.